A very good afternoon to you all and welcome to our live webinar, Get Ready for Cabin Air Standard ISO 23875, brought to you by Trisim Auto Electrical Engineering and Cyclone, and hosted by Mining Review Africa. Safety in mining operations is of concern to all involved in owning, developing, managing and working in mining environments. With a rise in the number of countries regulating air quality in mining, construction and industrial environments, machine manufacturers and mine owners have become increasingly aware of the need for standard practices in the design and performance of operator enclosures. ISO 23875 is an international standard for a consistent approach to maintaining these air quality systems. So how do we harness the benefits of the standard to improve safety, efficiency, and overall performance in mining operations? I'm Taryn Bolton, Managing Editor for Mining Review Africa, and today we are discussing Cabin Air Standard ISO 23875 and how it can improve operator alertness, create a safer work environment, and increase productivity. For the next hour, we will be discussing this international standard with a focus on a consistent approach to designing, testing, operating and maintaining the air quality systems of operating enclosures. Joining me today to unpack this topic is an esteemed panel of experts. I'm joined by Jeff Moredock, ISO Working Group Lead, Luis Fernandez, Global Account Manager at Cyclone International, and Douglas van der Reyt, New Business Development Africa at Trisim Auto Electrical Engineering. Gentlemen, thank you for joining me today. Before we kick off, just a reminder to you, the audience, to submit any questions you may have for our panelists. Simply pop your questions into the chat box, and please remember to include your name and where you are from, and if you would like a particular panelist to answer your question. Also, I invite you to take part in our poll questions during this webinar, the first of which is coming up on your screen now. The first question is, how familiar are you with ISO 23875? The options are not at all familiar, quite familiar, or very familiar. I will give you a few seconds to make your choice. You just click on your option on the screen, and the results of this poll will be announced during the course of the webinar. I'll repeat the question. The first question, how familiar are you with ISO 23875? Options are not at all familiar, quite familiar, very familiar. Right, now I'd like to kick off our discussion with you, Doug, to provide an opening and some background into the adoption of the ISO 23875 standard.
Thank you very much, Taryn, and good afternoon, ladies and gentlemen. Thank you so much for taking the time to attend this. On behalf of Trisim, I'd also very much like to thank Jeff and Luis for being present to share their knowledge, and also to share on something that is also very serious to Trisim and is quite a big part of our safety and health portfolio. So some of you may remember we actually had this webinar 2 years ago when the ISO 23875 was first published. It's 2 years on, and yeah, the purpose of this webinar will be to just go into more detail around what's happened in the last 2 years, and hopefully also to provide the info that you would require to implement ISO on your mine sites or wherever you are, and all the details. So once again, welcome, and I trust that you'll enjoy the show.
Thank you, Doug. Okay, Jeff, I'd like to now hand over to you, please, to provide some insights into the review and update on the global adoption and implementation of ISO 23875, the path to compliant air quality.
Thank you, Taryn, and thank you, Douglas, and thank you those who are participating in the webinar this afternoon. I'd like to take just a couple of minutes and or a few seconds here and kind of give you what's happened in the last 2 years. The standard was developed as a result of the problems we have in air quality in mining environments around the world, and the request and the responsibility on my side was to help organize a working group that would develop a standard designed to protect operators and operator enclosures in mining environments. We did that through Technical Committee 82 Mining, which is an ISO technical committee. And I'm very pleased to say that we were successful, obviously, in getting the standard published back in February of 2021. Since that time, we have been actively out educating around the standard and have found lots of interest around the world in the topic of air quality, specifically around qualitative aspects of air quality, like silica and the problems that silica presents to our operators. But it's not just silica, it's just generally speaking, air quality and the opportunity to improve air quality is what the standard is all about. I think the thing that is important to recognize, having had the standard in place for 2 years, is that it's gotten a lot of use and an opportunity for us to see what's working and what is not working in the standard. I would say that overall we're extremely pleased to see both the adoption and the success. We are tracking the installations, we're tracking the results from our industrial hygienists regarding their actual air quality findings, and the standard is performing up to expectation. So this has actually been fantastic news, and it means that we are doing a good job in the standard in getting the job done. So I just wanted to say that initially. Let me say, as it relates to the standard itself, I'm going to talk very briefly. I'm going to assume that most people are familiar with the standard, so I'm not going to do what we did 2 years ago and drill way down into it. But I do want to say that we are concerned about not only silica as it relates to air quality in the cab, but we're also concerned about operator fatigue. And so the standard addresses two things. It addresses particulate matter in the cab and keeping the particles out of the cab. That would be silica and anything else that happens to be in the air in the mine site. But it has a focus as well on making sure that the CO2, which is being generated by the operator inside of the operator enclosure, is continuously diluted so that we have adequate oxygen in the cab so that the operator does not experience mental lapses. Sometimes those are called fatigue events. And so the focus of the standard is on operator alertness and awareness and providing good operator air quality. So all those things are a part of our control process as it relates to the engineering controls that are in the standard. Next slide, please. One of the things that we've realized is that if we can control the amount of air that's coming in the cab and we can bring it into the cab clean or cleanly, then the operator has a chance. But to do that, we have to do certain things. We have to make sure that the filters that are used in the cab, both on the intake air side, the air that's coming from outside the cab, that air is being brought in to replenish the O2 or the oxygen in the cab. And it's also being brought in to pressurize the cab. So we want to create a positive pressure inside the cab, which prevents the particles from coming in through various cracks that may exist in the cab that would allow air to pass. So we're keeping an airflow in one direction. It comes from the outside to the inside and then back outside, and we're bringing it in clean. And then the air that is in the cab is often contaminated with particles that are brought in on the clothes of the operator. So when they come in, they open the door. If there's ambient dust outside, it comes in the cab with them. The question is, what does the cab do with that dust? And the answer is, in the absence of a way to move the air through a filtration system, it's just going to reside inside the cab, and it's going to be permanently, well, it will be continuously contaminating the air inside the cab. So we've got to remove that. And the way we do that is we provide a high efficiency filter on the recirculation side of the airflow, so that the particles are continuously being removed from the air. And then the last thing here is we're going to make sure that we're bringing in enough air to pressurize the cab to keep the particles from coming in into the cab through the cracks and leakages in the cab. And lastly, we're going to monitor all of that, and we're going to make sure that we're bringing in enough intake air into the cab to keep the CO2 levels down and the O2 levels where they need to be. And we're going to monitor the cab pressurization to make sure that we're not allowing the particles to come in through the leakages in the cab. Next slide, please. I think the important thing to recognize is that all of that is great, but if you don't have a way to test the cab to ensure that it's actually doing what we have designed in the standard for it to do, then the system is not providing to the operator what it needs to be providing. So we've, in the standard, we've developed 4 very simple tests that can be done that quickly determine if the cab is performing as it should be performing. And some of the interesting things about that, we're going to look at CO2 and the way we're going to test for CO2 in the cab, and we're going to look at how long it takes for the dust that's brought into the cab for it to leave the cab, that is to be taken out by the filtration system. Interestingly enough, just as a point of reference, we're expecting it to go from a level of 2,000 micrograms per cubic meter of concentration down to 25 within 2 minutes, which means this cab is really effective in pulling those particles out of the air. And then we're going to test the cab pressurization system. That's easy enough to do. You see if it's pressurized and you record the pressure. And then we're going to look at, we have another test to look at any leakages which may exist in the low pressure side of the system. Now, all of that to say that the way the standard was designed, it was designed for everybody to use, not just for the factory to build a machine and do these tests, and that's the last time the testing was done. It's designed for the testing to be an ongoing process, because as the machine is maintained, the air quality system will be taken apart as they disassemble the machine and put back together again, and it may happen many times during the life of the machine. In each instance, when it's put back together again, we want to make sure that the system is still performing. So the performance testing has to be accessible to everybody that's a stakeholder in this process, which would mean the occupational hygienist who wants to know that it's working to protect the operator, and then of course the site maintenance people on the reliability engineering side at the mine. Each one of these stakeholder groups has an interest in making sure that the cab continuously performs. And this testing, which is made simple so that everybody can participate in that and can do the testing, allows for that process to take place. Next slide, please. So I think the thing that is most important here relative to the standard is that if the standard is working, then that means that it's that we are doing what we were asked to do relative to the creation of the standard. And the way that we know that it's working is adoption. Who is benefiting from this and seeing the benefit and then saying, hey, this is something that we need to make a part of what we're doing. And the interesting thing here is that because the standard facilitates the needs of the OEM, of the retrofitter, of the occupational hygienist, of the reliability engineer, in fact, all the way up to the CEO of the company, this standard has become recently adopted. I'm going to give you some examples here of the adoption. It has been adopted by Australia. It's now Australian standard / New Zealand standard ISO 23875. So they have made it their own, and this is obviously very useful for their country as they're very aggressively going after air quality issues as it relates to operator enclosures and mining environments. Similarly, the European Union adopted it. It's European norm, ISO 23875. Sweden as a country adopted it. Colombia, South America adopted it as a standard. And then it is being used as a tool in the regulatory process around air quality to as a path for the regulators to get to good air quality and operator enclosures by providing a standard that articulates how to do these things. The regulator doesn't have to create them from nothing. They can't make them up because they're not engineers. They don't know how to do these things. What they're relying upon is industry, in this case the mining industry, to come up with a standard of its own that gets this done, and then they can step in and say, hey, this is working, you're using it, you're adopting it, we're going to make this part of our regulatory regimen, which means that now everybody can enjoy the benefits of doing it the same way and understanding what that process looks like. So it's brought a lot of clarity into the marketplace. Please, next slide. We all are aware that that worker health continues to be a problem around the world. Silica is not going away. The Earth's crust is 29% silica. Anytime we're digging in it, we are likely getting into silica as an issue. But it's not just silica; it's all the dust that we generate when we are cutting and abrading and digging in the ground. So I think that from the standpoint of understanding what the problem is, public awareness of the problem is at an all-time high. And that would be true for everybody around the world. There's an acute awareness that what you breathe does have an impact on your health. Next slide. So what are the reasons behind why the standard is being adopted? Well, at the corporate level, it's because it's consistent with the core values of the company. I mean, companies don't want to hurt their employees, quite the opposite. They want to protect their employees. So when they have a standard that fits into their occupational health and safety management program that allows them to offer a higher level of protection to their workers, this is something that they would be very interested in doing. And candidly, they have a reputation to protect. So all companies are concerned that their employees are taken care of because they want them to stay there and they want them to work. We need them in the mines, we need them working. Now, on the regulatory side, I've just spoken to that, but it really represents for the regulation a win-win. When industry adopts something and demonstrate that it works and they're using it outside of regulation, then making it part of a regulatory process makes perfect sense because it's consistent with what's already being done. And one important note here, I have on the right here of the screen, there's an upside down triangle, and that's dealing with what we call the hierarchy of controls as it relates to the way that operators in an operator cab should be protected. PPE, that is things that you're going to physically put on your face to protect you from dust, that is not considered an acceptable way of dealing with dust inside of a cab. It's very hard for somebody to put something on and wear it 8 hours a day or 12 hours a day inside of an operator enclosure. So what we're looking at here in the hierarchy is what are the other ways that we can control it, and engineering controls, which is right in the middle, is where this standard is. It's saying we have an engineering control process that we implement on the machine that allows for the operator not to have to wear a face mask all day, which obviously makes him a lot happier, or the person a lot happier about being in that cabin working. So providing good air quality it has to do with the heating and the cooling, obviously. It has to do with particulate. It has to do with giving them enough oxygen so that they can work and have a sense of wholeness and wellness inside the cab when they're operating. Next slide, please. I've already addressed many of these things. I just would add to this that in the United States, the Mine Safety Health Administration commented on the standard when it was being written. We are in the process in the United States of modifying the MSHA silica regulation, and the silica threshold is being lowered from 100 to 50 micrograms with an action level of 25, which is perfectly consistent with what the standard is designed to do. The standard is designed to provide 25 micrograms worth of concentration or less in the cab. This is where MSHA is going in the United States and where Australia has already gone, and is consistent with the other countries and their regulatory processes, at least the way they're looking at it at this point. Next slide. The last thing I would say here is that as we look around the world about how the process is happening quickly, we see that there's going to be a period of time, and this is Jeff's opinion here, but looking at the different countries, and I've just cited some of them, and how long it's going to take for industry to get this, to get cabs taken care of. And I've speculated on this, but with an effort in each one of these countries, depending on the level of that effort, we're seeing between the regulatory adoption, between the adoption of the standard as a national standard and industry getting behind air quality solutions. This is my estimation of how long it's going to be before we see these systems implemented on the machines that are existing in the mining environment in their countries. So this gives you an idea of what we're looking at. Next slide. Lastly, if you want further education on ISO 23875, I would strongly recommend that you go to the iseee.net website, and you can take a class online anytime you'd like to take the class. That will instruct you on the certification process around the standard and how it works. If you are looking for a good class that gives you really excellent templates that you can use in your occupational health and safety management program, this would be the place to go. Strongly recommend it. And next slide, please. Yeah, I thank you very much for your time, and I appreciate any questions that you have. Look forward to answering them. Thank you.
Thank you so much, Jeff, into those insights into the adoption, performance testing, and benefits of the standard. I would now like to cross over to Lewis. And Lewis, if you can take us through how to meet the ISO 23875 performance requirements, and also provide some background, if you can, into the Cyclone company and product parts as part of your discussion.
Yeah, I am
No
Luis
problem.
Fernandez, and again, thank you for being here. Welcome to this webinar. I think I'm super excited to be part of this movement, from this global movement, and be part of the company, because one of my missions and my passion here at the company is to make sure that some areas, starting from South Africa, Canada, Mexico, LATAM, etc., are able to recognize or to be able to be complained, so ISO 23275 complained, and get the most important thing here is just to get the benefit of the clean air, because at the end of the day, what we provide as a Cyclone, we don't provide products. We provide just clean air to the operators, to the engines. So this is what we do. Just some things about the company, so you can have a quick picture about the company. So this is Cyclone International. It's a privately held corporation established in Jacksonville in 1986. Employs more than 70, I don't have the exact number, but 70 people at the company. We manufacture pre-cleaners, and we sell the pre-cleaners basically across the six continents. And I think this is important to let you know about air filtrations, innovations, and global reach. We do have more than 100 patents and trademarks for air filtration and preclinical innovations. We work. This is very interesting as well, because we work with 10 of the, let's say, 10 of the top 10 global construction OEMs in the world. So like Caterpillar, Komatsu, etc. So they use our products because they recognize the value. And yeah, let me just tell you something a little bit before going into the products. You can just change the slide, please, to the next one. Here we go. Fantastic. Before going to that one, where you have the channel, basically by using our products, you can have, let's say, a perfect air into your cap. But let me just tell you something before that, because I think this is the important thing here, is like the benefit of having a clean air. And I think this is very important to know. So basically, by using our RESPA systems or our Cyclone cap systems and filters, you keep, and this is the point of this, you keep your crew safer and more comfortable in the cap, while you have the machine running longer. So this is one of the important things. I have just 3 points, and then I'm gonna jump on the products. So basically, point number 1 is improve operator health and safety, because you are reducing occupational exposure to respirable dust and debris, which may reduce risk of chronic lower lung disease. Number 2, increase operator comfort, because you are using, or you have a well-running HVAC system, improving of course, 100% the operator environment and support employee retention and recruitment. And the last point is, which is as well important, you are reducing the HVAC maintenance cost, because the evaporator core remains clean. So at the end of the day, you are improving the machine uptime and productivity, and with less service intervals. Basically, what you have here is 3 systems, our cap systems. Basically, one of them is the fresh air system, which is the RESPA, that provides, you will see in the next slide, we provide fresh air intake to the cap. No, you can just, excuse me, go back one slide. Just go back, excellent, yeah. So we have 3. The first one is the pressurizer, which is the RESPA that provides fresh air to the cap. The second one which is part of this important process, is the recirculation unit, which basically goes inside to the cab in order to let's say to prepare to get back the clean air to the cab. And then we use our filters, HEPA or EPA, ISO compliant, and then the third and is one of the important things, like you have an immediate lecture reading about what is happening on the cab. So we have a monitor that basically gives to the operator the situation in the cab about the CO2, the pressure, the life, like the filter life, etc. So by using these three cab air quality systems, you will have the benefit to get a clean air and be an ISO 20075 compliant. So yeah, next slide, please. Here you go. This is probably one of the main systems. So this is a pressurizer, and basically we call RESPA. So we are providing fresh air to the cab by using this. Of course, we have to have a properly sealed cab, of course, 100%. And yeah, you can change to the next one, please. Excellent. So basically here we have our filters that basically we use in our systems every time. So you can see, for example, the efficiency on this case under the ISO 20075 amendment. So the let's say the minimum efficiency recommended is 94% over a 0.3 micron, and then on the HEPA filters is 99.99 to 0.3 micron. So this is that. I mean, we use and we make our filter at home. And basically, I think this is something interesting that we test every single filter before we ship to our customers. Yeah, you can just change the slide, please. Yeah, just here we go. Yeah, so this is what we mentioned before is part of the ISO. So with this device, we are providing like a lively reading to the operator about the CO2 levels, the pressure that is basically on the cab, and also the filter situations. So you are helping basically right away the operator to monitor or to see what's going on in the cab and just have the right conditions daily. Without any monitor installed, you don't have a way to feel what is happening into the cab. So yeah, you can just change, please, the slide. There we go. Yeah, at the end of the day, you know, we are not promoting. We are happy to show to our global minds, customers, to our distributor, to our OEMs and users, etc., how they can be providing clean air to the operators. So this is basically the vehicle or the channel to get that benefit. Of course, I can spend just a couple of seconds here about talking about the engines, because this is just a cab air quality systems, but we do provide as well, and I think this is important to mention here. We provide as well a power cleaner systems that basically help the machines to protect, first of all, the engine, which is one of the expensive parts of the machines. So we are protecting the engine, and then second, we are providing like a long life to the engine filter, which is the primary secondary filters, and then we are working, or excuse me, we are helping to that machine to be like a running more time, and then with less maintenance intervals, etc., by using a power cleaner for the engines. So basically, it's very similar to the RESPA. One of the differences is like is mounted close to the engine, but the technology is very similar. Yeah, I think, yeah, can we go to the next one, please? Yeah, I think of this case, if Jeff wants to share a little bit of this one.
Yes, thank you so much, Luis, for that background. Jeff, Luis is absolutely correct. So I suppose as an extension of your discussion on performance testing, can you take us through a case study into cabin air quality, which focused on delivering clean air at a site which had a fibrous environment?
Right. I think it's important to see graphically when we talk about air quality what this actually looks like. So what you're seeing in front of you is are two dust lines. In other words, we were taking the dust concentration levels in two cabs. The cab on the top is a factory standard cab. It does have a pressurizer on it, but it has an inefficient filter. That is a filter that's allowing the particles in the range that is problematic for the human being into the cab. And you can see the quantity here. I think the thing that to notice most importantly is that, first of all, the dust is going up and down in the cab, and that's because the door is being opened and closed. The cab is a drill cab. You can see the picture on the right. There's 3 drills running on formation. One of the drills has been retrofitted for 2375 compliance. The other one has not. It's a factory cab, and you can see that the dust, how the dust is being treated by the cab is very different from the top to the bottom. The red line there is 50 micrograms. The goal in this particular jurisdiction was to keep it below 50. You can see the factory configuration never even got close to that, and that when the door was open, it took a long time for the dust to leave the inside of the cab. It just hung around in there in a higher concentration. On the bottom, you see what a 2375 cab actually does in the data. So we have a cab that's running right next to the other one, the same operator getting in and out, in and out, in and out. And yet the cab seems to be, first of all, operating at a very low level of dust concentration in the cab. And then when the door is open and the dust comes in and you see those spikes, immediately it's pulled back out and dropped back down below that red line. What we found out was that this cab, we were doing 2 tests on it. Well, one of it was real time, the other one, meaning that the data was being given to us immediately. The other one was we were doing a filter test and that we had to send the filter off to the lab and have it analyzed to determine dust concentration. But in this instance, on the bottom, the operator was being exposed to less than 5 micrograms of silica. And the threshold limit was 50, and the threshold limit for the standard is 25, and he was at below 5. And we tested this many times, and each time it actually got lower. So I just wanted to graphically demonstrate to you the power of 23875 in the real world mining environment in hard conditions to be able to give the operator an air quality which meets the local requirements of either the company or the region or state that they are in. So thank you very much for that.
Great, thank you, Jeff. If we can just look at to Jeff, so given the number of countries that have actually adopted the standard, when do you think South Africa will be adopting it?
Well, I want to talk about that. That's a great question. That's a really good question. Salient for that is spot on for what we're talking about here today. I think 2 things have to happen. There needs to be industry adoption. It's going to happen before regulatory adoption. Meaning our industries, our mining operations in South Africa need to adopt the use of the standard and be talking about it as a way that they're getting to compliance either with internal policies around dust exposures or around current regulatory pressure on or requirements around dust exposure. This is the kind of thing that doesn't happen instantly at the regulatory level or at the adoption level. It has to be something that is recognized as valuable by the stakeholders that are participating in the process of keeping operators, in this case operators, safe in relative to air quality. So I think there's a 2-step process here. I'm going to be I'm going to be down in Africa for the next couple of weeks. We're going to be talking to a lot of people, very excited about that. There's a lot of details here, obviously, that need to be addressed. Ultimately, I see there will come a day, I believe, and it's not in that distant of a future when it will be adopted either as a national standard or implemented in some way into the regulatory process. How long is that going to take? Boy, I wish I knew the answer to that question. I wish I could answer that for every country in the world. The dynamic is different in each country. I will tell you though that there's a huge focus on this, and I think we're going to make good progress, and I'm excited to see how it all works out.
Okay, so on that, what would you say is the biggest obstacle to implementing the standard?
I think the biggest, I think it's just people understanding what it is. You know, when we hear about, everybody has their own understanding of what an ISO standard is, depending on how you've interfaced with standards. And you can either perceive that as a good thing or a bad thing, or a neutral thing. And we need to have people looking at this particular standard and really understanding what it is. I have found that many times standards are so high level that people that are having to interface with a machine, while the machine might have been built to a standard, doesn't mean anything to them. But this standard is different. This standard is for the person maintaining the machine. That's who it was written for. It's written for the company that has to run that machine for years. And so while it does have an application to the OEM and to the retrofit of a machine initially, the focus is the life cycle of that machine. We're focusing on, listen, you got to run that machine for 20 years. What's the air quality going to look like in the cab in 10 years? So I think that a lot of this has to do with education, and hence I've been on the world tour this year. I've been traveling all over the world talking to a lot of people, and the primary focus is just getting people to really understand what the standard's all about. I believe, because this has been the response that I've seen and received, when you understand what it's doing, you understand how it does it, you'll completely get on board with the standard, because it is designed for everybody in the process. Everybody that's a stakeholder is a winner in this standard, and I think that's important to do. So education, I'd say that's the biggest obstacle.
Okay, so once a system is installed, or the systems are installed, how would you get machine operators and maintenance departments to keep the system up and running?
Yeah, man, that is a great question. Once again, it gets back to education. The standard lays out in Annex B how to do that. And because it's an occupational health and safety management system, it's a process that has to be in place on the mine site. So that process affects the actual paperwork that's being done, because it's an auditable process. It affects the culture in the mine site. You know, if you're asking people to go someplace and you don't give them a map, they just wander around in circles. They can't get there, so they get frustrated. And then whatever you said for them to do gets thrown out because they're frustrated over it. But in this instance, we're talking about a standard that lays out a path. It's a road, and you get on the road, and that process takes you to clean air and a cab that's maintained over the life of the machine. And that process is transparent. Everybody knows what's going on. Now, how do they get to that point of understanding the process? That's an education piece. Again, we are working, when I say we, the International Society of Environmental Enclosure Engineers and others, corporate-wise, are working, and in many cases working together, to develop the education program that will help facilitate this at the local mine site. Now, understand that we're also working with a standard that's 2 years old, getting out ahead of these education needs. And we totally understand that the education is critical. We're working on that. We invite anybody that's listening today, and any mining company or industrial hygiene company that wants to get involved in the process of developing that education or being participating in that process, we invite them to do so. Because in the end, we understand that without good education, you cannot get this implemented. You know, if you don't teach somebody how to read, you can't blame them for not reading. And it's the same thing here. We have to educate, and that's really the process that we're involved in a very big way right now.
Okay, so absolutely, because my next question would have been, is there training available for the maintenance department personnel on the standard?
Yes, and the answer is yes. It is available today. I think that as a starting point in terms of understanding what the standard is all about, if you go to the ISEEE.net website and you click on the button right on the very front screen that says learn more about ISO 23875, you'll be taken to the online course. That course, by the way, ICE is an international not-for-profit. All right, it has one purpose: to protect operators in their cabs. That's what the organization does. That's the function of the organization. And education is the tool that it uses to help get this done. And the members of the organization, candidly, many of them were people who wrote the standard in the first place. So they have a really good idea what we're trying to get done on the education component, because we wrote, this is the group of people that at least many of them that helped write the standard in the first place. So I would go to ICE, I would start there. It's going to give you critical templates. That is, It's going to give you stuff that you would have to make up on your own. We're saying you don't have to make it up. We take section 6 of the standard, which is the maintenance manual requirement, and we give you the template for that, and we lay it out. So I would say if you start there, you're going to be a lot smarter on the standard. You'll understand what the standard's all about, how it works, how to do the certification process. It'll help you to audit. It'll help you to understand how to buy the parts. It'll help you understand how to be a more effective consumer of the standard as it relates to implementation on your mine site.
Okay. And then just, Jeff, one last thing for now. What did you mean, or what do you mean rather, when you say the standard was the path to compliant air quality? What is that?
Yeah, I thank you for that question. That's a very insightful question. So I think the issue here is understanding that that if you get on the road we call ISO 23875, it takes you to good air quality. It is the path. It's the way you get there. And there's been a lot of confusion around this. Some people say, well, you know, there's a lot of ways to get there. No, they're not. I'm not saying that the words ISO 23875 have any magic associated with them. But what ISO 23875 does is it takes the engineering understanding, it takes the laws of physics, applies to the operator cab and says, listen, we have to pressurize a cab. We have to provide high efficiency filtration to take the particles out of the air. These things are obvious, but we're going to organize them in a way that everybody can do it and understand it internationally. So we're doing it the same way, but the tools are the same. Whatever you're going to call it, we call it ISO 23875. It is the path to operational air quality, for good air quality and operator enclosures. It is the way you get there. So that's what is meant by that.
Okay, thank you so much. I think at this point, I'd like to read out the results of our first poll question. Right, so let's have a look at those results. If any of the panelists would like to comment on this, I don't know if you'd expected this kind of answer. So it looks like we're weighing quite heavily on the not at all familiar. Jeff, in fact, if you'd like to comment on the results here.
Yeah, I would say I'm pretty happy with these results. I mean, to say we're 50% not familiar with the standard doesn't surprise me. To say we're 40% quite familiar is really encouraging. Okay, that means that the word is getting out and the message is being heard. Very familiar, I would interpret as these are people who have actually read the standard. So quite familiar to me means people that have heard about it a lot, heard discussions around it, have been participating in those discussions. But we say we're very familiar. These are the people who probably have actually read the standard. That's great. Hopefully the 50% of the people that said they're not very familiar with the standard at this point have been enlightened to the fact that a standard exists that addresses air quality and solves so many of the issues that we have at our mine sites relative to maintenance of our air quality systems, or that would be the HVAC, as well as the operational, the air quality in the operating environment during normal mining operations. And if you've just gotten that out of this, now you know there's a path forward, there's hope, there's a lot of hope here. These are problems that can be solved. Respirable illness can be addressed by not exposing our operators in the first place. We can get away from PPE, we can increase operator happiness, we can do a lot better job. And this is the path, this is one of the paths, and this is a very clear path relative to this topic to get there. So I'm encouraged by those results.
Okay, great, thank you. Lewis, if I can move on to you now. Are the performance tests able to be performed after initial installation? So when we talk about performance testing, after initial installation, are these tests able to be performed? Sorry, Lewis, I think you're on mute.
Yeah, sorry again. Yeah, you mean once we so the question was once we install the products?
Yes. So after initial installation, are performance tests able to be performed?
That's right. Basically, I mean, this is a great question also, but I think this is also this part. I mean, we can start seeing after some period of time. I mean, for example, a couple of weeks or so. It's depending on the machine, etc. But we see, or basically our operators, and this is something that we hear constantly, that basically they start feeling or breathing the clean air, basically once we install the product. So this is basically the immediate outcome is just breathing differently. We had the chance to interview not tons but many operator machines when they are like running the machines, and it's not because our products are great. I mean, are great, of course, but this is something that let me be honest. They work. They work, and when you talk to the operator, even if it's a hot rock operator, excavator, etc., and they have our Respar, our product installed, then you can hear from them that the air is very good, it's very clean. Of course, we have to be monitoring every time the cab, etc., because we need to provide clean air for, as Jeff mentioned, not just for one day, but the idea is to provide for a lot of years this clean air. So the let's say the outcome is very interesting, and this is why we are focused and we believe on this. South Africa is one of the it's an historical mining area. So this is why we are super excited to not to promote but to establish this ISO 375 in South Africa, because I know that the operators are needing this and are looking for this solution. So yeah.
Okay, thank you. I'm just doing a time check. We have about just over 10 minutes left. I'd just like to go to Doug quickly. So Doug, what is being done in South Africa to get the standard adopted at our local mine sites?
Thank you, and that's also an excellent question. So just to allude back to what Jeff said, I think a big focus has been put on education, spreading the word, clearing up misunderstandings, and also helping our clients to understand and to look at this in terms of their roadmaps. And getting the right people involved is very important. So you would have your occupational hygienists, your reliability engineers. There's a whole range of decision makers and role players on all of our sites. So yeah, I think at the moment, remember the ISO 23875 is only 2 years old. So yeah, we need to, and we have been focusing a lot on education and making people aware, and then also obviously assisting, because we have had questions. Okay, we agree with this ISO 23875. What next? How do we implement? How do we measure, etc. Yeah, so that's basically, I'd say, education and engagement currently are the biggest ones. Thank you.
Okay, I see quite a number of questions coming in from our audience. Before I pose these questions, I wonder if we have time to take part in a second poll. So I think while I'm addressing those audience questions, let's put up the second poll quickly. What safety controls is your company currently using for dust suppression? And then your options are PPE and personal respirators, cab air filters, on-site dust suppression, such as water trucks, misters, or other, or none of the above. So while we address some audience questions, let's look at the poll. I'll read it again. What safety controls is your company currently using for dust suppression? PPE and personal respirators, cab air filters, on-site dust suppression such as water trucks, misters, or other, or none of the above. Okay, and while that poll question is still up, let's go to some audience questions. For Doug, what feedback has the standard received from other countries in Africa? So we touched on South Africa. What kind of feedback has there been from other countries in Africa?
All right. Okay. Also, I love the question. Thank you. Part of my focus is working in countries outside of Africa. So first off, I'd say the majority of the mines and clients we have outside of Africa are showing an increasing awareness and concern and seriousness about the air quality in their cabs, and a lot of doing a lot of studies, which has really been encouraging, and it's been wonderful working with a lot of these companies for more than 2 years before the ISO 23875 was released, on air quality and concerns. So yes, I'd say the awareness is definitely growing and the interest is definitely growing, and we continue to reach out. And also bearing in mind a lot of your African mining houses are global, so that's also another strategy that has been employed to reach all the sites, is obviously through head office, in collaboration with Jeff and so forth. Thank you.
Absolutely. And then there's another question here for Jeff. So what is the biggest decision-making criteria when evaluating cab air quality or filtration? If you'd like me to repeat the question, sorry. What is the biggest decision-making criteria when evaluating cab air quality or filtration?
All right, I'm going to address this. There's probably more than one answer to that question. Looking at it from an industrial hygienist perspective, what are they looking at? And I think it has to do just with they're going to do measurements in the cab, and they're going to do measurements on the operator. And so one of the biggest issues for them is, are we exceeding our threshold limits? Am I in compliance or am I out of compliance? Is the person being overexposed? Are we okay? So if just purely on the health side of the equation, that is the critical thing. Now, there's a financial component to this, which in the absence of data, in other words, if you don't know that the operator is being overexposed and you're speculating as to the effectiveness of your control processes that you have, then one of the big points can be, am I going to have to spend money that's going to change? What's it going to cost me to change what I'm doing? And this gets back to the first one, which is, if you don't have a motivation to change, if you don't realize you have a problem, if you're not testing, if you don't have any particular pressure to meet a threshold, or if the threshold doesn't exist, then naturally the big criterion is going to be, hey, I kind of get it. I like the idea of improving air quality, but what is it going to cost me to do that? And I think the thing that's exciting about this is that you can have both. You can have good air quality and not have to spend the earth for it. One of the things that's not commonly understood is that HVAC systems in cabs don't like dirt. Even if the operator's not in them, they don't like dirt. They break the cab, they break the electronics, they break the HVAC system. So if you're spending money, and if you're running in a hot environment, we know that's often the case, and you want to keep a guy in an environment that he's willing to work in an enclosed cab, the HVAC has to work. And if it stops working and the guy won't work, that's lost production, lost downtime, and the cost of the repair on the machine. So the goal is to keep the whole system clean, not just the guy's lungs. That's one of the effects of the whole thing, is you keep the guy in good health. That's a major piece. But understand that from a reliability engineering perspective, the guy that's got to make sure the cabs, we have uptime and productivity on HVAC has to do with dirt. If you can keep the dirt off the HVAC, your HVAC goes from planned maintenance to planned maintenance without a failure. You cut down on a lot of lost downtime, all associated with the inability to keep the HVAC running. So this is a part of the financial equation that many companies would make a decision just on that, because the numbers are so good, the cost versus the benefit. So understand all these play together depending on which of the stakeholders you're talking to and what data is actually being collected at the site.
Right, Jeff. So I actually think you've answered a portion of another audience question, which is also for you. Are there other benefits to a company to adopt the standard other than the health and safety benefits?
Yeah, I mean,
I think you have responded.
Yeah, I think we've got a mechanical aspect, which is the HVAC, but I think there's a lot more to it than that. I mean, candidly, what the company wants is they want a transparent process internally that can be audited internally, where the CEO knows when he's being interviewed by, Meet the Press or whoever it is, and they ask, well, what are we doing about air quality? He can say affirmatively, our company is doing this, and know for a fact it is being done. You can't do that if you don't have a process that's auditable. And that's the beauty of the standard. The standard lays out a process which is designed for everybody in the system, all the stakeholders who touch it, to understand where they are and what their responsibilities are, to ultimately to the CEO who's making representations about what the company may or may not be doing as it relates to this topic. So benefits the benefits extend to all of the stakeholder groups, not just to the maintenance guy, not just to the retrofit or whoever it is. Everybody wins. And I have to say something. If everybody doesn't win, the standard will never work. If there's a loser, it'll never work. It only works because everybody wins. And I will tell you that everybody that's in that stakeholder chain, every one of them commented on that standard. We actively sought out everybody and their brother to give comments on the standard because we understood it has to be owned by everybody, not just the company or the IH, or no, it has to be the property of everybody. And if we succeed in getting that done and they understand it, we can educate people to understand that this is how the system works and they can read it for themselves, we will win. We will see a lot better compliance around operator air quality.
Okay, great, thank you. That's a great analogy. I think we are really running short on time, so I'd like to go to Doug, and in closing, can you please provide some wrap-up recommendations for the operational integration of the air quality control system, which was discussed in this forum? So in other words, Doug, if you can wrap this up for us.
Awesome. Thank you first of all to everyone who's been involved, our audience with the awesome questions, all the organizers, to Jeff and Luis, all the people in the back end for making this happen. So in closing, I am sure that most of the audience still has quite a few questions. Yeah, you know, how do we implement this? How do we gain the knowledge? So I would encourage you just to reach out to us. We as TRISIM have access to Jeff and a lot of assistance. We can basically working together as a team, you know, assist, educate, and also help to get programs going down the line. So really appreciate it from all of us to everybody. Thank you.
Yes, thank you. So to our audience and viewers, you can reach out to Doug and TRISIM for any unanswered questions. I think this webinar should have been a little longer to answer all those questions. Before we wrap up, let's see the results of our second poll. Right, so, wow, that's pretty much an even aside from cab filters. Anyone care to comment on that, Doug? If you can see the percentages, Doug?
Yes, I think we'd agree. That's pretty much, I think, what we all expected. Cab air filtration, I think that's pretty much a new thing that we're talking about in terms of ISO 23875. So hoping that'll grow. But thank you to everybody for that feedback.
Right, thank you, gentlemen, for those insights into ISO 23875, placing a greater emphasis on the air quality inside the cabin than ever before, thus defining it as a life cycle standard. A reminder to our audience, if you missed part of the discussion or would like to watch this webinar again, you can do so on demand, which will be made available soon on miningreview.com. Thank you to our panelists and to the audience for joining us today, and a special thank you to TRISIM Engineering and Cyclone for sponsoring this insightful webinar. Until next time, goodbye.